Hello, hello, hello. Is this working? Hello, hello, hello. Yes, it is. Great. Um, so today I want to drill down further into something I was looking at the pub. I was looking at um, the spin of electrons and how they are, um, their position is based on a scale of probability. I found this fascinating. And I'd like to take a look at some of those equations. Um, and if I get too bored, then I'm going to probably open up. By the way, there's a fly here. Come on. Okay, sorry. I'm going to start to write some tooling in Python to allow me to put together some kind of demonstrations of the stuff I'm learning. I don't think I'll get onto that, but we'll see how it goes. So I'll start off as normal, just the Greek lesson. Oh, and also, what are we celebrating? Let's see. Not a lot, but my friend was diagnosed with something called fibromyalgia or myalgia, which is fiber pain. So joint pain basically, and it's also got some other depression and emotional kind of disconnection that happens. So here's to that, and I'm sorry to hear that, but got your back. And also it's funny because we on this channel we're learning about or we'll be learning about the nervous system. It would be great to focus in on that problem to try and learn something about it and see what we can do. Anyway, uh, yeah, cheers. Oh, I haven't had wine for a very long time. That's very nice. Okay, cool. Let's do this. So keyboard up. I've got those little flies flying everywhere. Must have left the window open at some time. Um, okay, what are we on? This is finished. So Greek. Form of S. Let's do that. Start. Can I hear anything is the question. Should be able to. Match the pairs. Me. Oh man, I don't think the...
Σκο,
Okay, it is working. Great. Me. And that will be this one.
με, σκο,
Score will be that one. Sin. Sin, sin.
συν,
Seal, seal.
σίο, κους,
Couscous.
κους,
What do you hear?
κους,
Course.
κους,
Match the pairs. Course, course.
κους,
Stare.
στε,
Stare. Score.
σκο,
Score. Sin,
συν,
sin, sail,
σίο,
sail. Select the correct characters for kus. Kus.
κους, κους,
What do you hear? Kus.
κους. Σουσάνα, το τόστ.
Susanna
Σουσάνα,
to
το τόστ.
toast. Susanna the toast. Susanna the toast.
Σουσάνα,
Susanna. Or Susanna, I guess.
Σουσάνα,
Okay, fine, we'll spell it differently. I thought that was her name, but anyway.
Σουσάνα. Σουσάνα, το σινεμά.
Susanna the cinema. It's toast. Oh, it is ine toast.
Σουσάνα, το κουσκούς.
Susanna the couscous. Water in the couscous. Oh no, that's the worst. Nero in the... Ooh, store. It might be store. Store, okay.
Στο, τόστ.
No, couscous.
Κουσκούς.
Couscous. Score.
Σκο, σκο,
Score.
σκο.
Great. He makes couscous. Autos. Aftos. Aftos makes. Kane. Kane couscous. Kani couscous. Aftos kane couscous. The toast is a snack. Toast is a In
Είναι
a snack.
snack.
Cool. That's awesome. Right, let's do this. So let me open up a OneNote. So we're gonna do a little bit of sidetracking, basically, because we were learning quite a cool amount of stuff about the electron shells. But yeah, at this pub, I found this article and I just thought, oh, that is just so interesting. So if I do, I can't remember what it was called, but let's look for position of electrons probability equation. How do you tell the position of an electron? I always yawn when I do this. Like, I don't find this boring, but it does sound like I find it boring. How do you determine the position of an electron? For example, you can measure the position of a moving electron by scattering light or other electrons from it. Yeah, that's interesting. Wow, really? I'm sorry, flies, but you guys are mating. We can't have that. This is a this is a children's channel. No, it's not actually. Get it on. Yeah, okay. Right. For example, you can measure the position of a moving electron by scattering light or other electrons from it. That's interesting because the way I read that is you scatter light. No, you scatter electrons by giving Planck's constant energy to get an electron from one of the shells, right? I don't know for sure. Let's just have a look at this anyway. This is not what I was reading, but it'll do. Heisenberg uncertainty theorem, great. Oh yeah, here's some formulas. That's what we want. Energy, change in energy over change in time. Yep. Change in x over change in, what is it, momentum or uncertainty and momentum? Yep. Change in EAT. Change in energy over time. What is this? Problems and exercises. Ooh, okay, that sounds good. So, let me zoom in. By the end of this section, you'll be able to use both versions of Heisenberg's uncertainty principle in calculations. X doubt. Explain the implication of Heisenberg's uncertainty principle for measurements. It's interesting. I don't think I knew I was reading Heisenberg uncertainty principle when I was looking at the thing at the pub. So I'm just going to try one more time. Electron position predictions. Try that. Could have been Socratic actually. I do. No, it wasn't that. Remember that name though. News.y combinator. No. Liber text. No, wasn't that. Read. I don't think it was those. Let me just check my phone. I should have prepared this actually. What did we go to just the other day? I've got it here. Yes, I've got it here. So it is hyperphysics electron spin. Hyperphysics electron spin. Yeah. Yes, this is it. Right. So you see here, an electron spin, S, equals 1/2, is an intrinsic property of electrons. Electrons have intrinsic angular momentum. Right, let me just make sure I understand what intrinsic means here. Oh my god, let me understand what intrinsic means. Belonging naturally, essential. Have essential angular momentum characterized by quantum number 1/2. So let's look at this quantum number 1/2. One of the electrons in an orbital is arbitrarily assigned an s quantum number of +1/2. The other is assigned an s quantum number of -1/2. Thus, it takes 3 quantum numbers to define an orbital but 4 quantum numbers to identify one of the electrons that can occupy the orbit. Oh my god, I'm so sorry. Wow, this is the worst stream ever. Yeah, I'm so sorry. Okay. One of the electrons in an orbital is arbitrarily assigned an s quantum number of plus 1/2. The other is assigned an s quantum number of minus 1/2. Okay. So let me just draw that because I'm getting a little confused. And let's go episode 17. Let's see what this is saying. So here's my atom. Here's an s orbital. One of the electrons in an orbital, okay, is arbitrarily assigned an s. Okay, so let's say this is electron electron 1, and this is electron 2, negative obviously. So this will be equals plus, so it's assigned an s quantum number. So let's do E1 E1 or S of E1. Doesn't really matter, does it really? Let's see, what's going to be the most? E1S and E2S, and this one is equal to plus 1/2, and this one is equal to a negative 1/2. Okay. Thus, it takes 3 quantum numbers to define an orbital, but 4 quantum numbers to identify one of the electrons that can occupy the orbital. What? Oh, I don't understand. Is this? Yeah, it is. Cool. So, let's look into this. The Bohr model was a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. So Bohr model used one-dimensional model. Bohr model was a one-dimensional model that used one quantum number to describe the distribution of electrons in the atom. Okay, fine. So let's do that. So Bohr model. And you've got one-dimensional. Whoa. One-dimensional. Quantum number describe the distribution of electrons in the atom. So there is a quantum number describes the distribution in electron in the atom. I use this symbol because it looks like it's being distributed. What is that one again? Can't remember. Yeah, okay, so the only information that was important was the size of the orbit. So, size of orbit, which is described by the n quantum number. N equals size of orbit. Schrodinger's model allowed the electron to occupy three-dimensional space. Schrodinger, so Schrodinger what is it? Something like H some shit over here. I can't remember. Let's go and look at Schrodinger's equation. Schrodinger's equation. What is it? Oh, we've got some symbols. Oh. Hamilton operator multiplied by the wave function equals the energy of the wave function. I don't remember it being like that. I remember it being more like this. The equality here is I hat over the change in the wave function over time. So this is what I remember it being. Yeah. Okay. Minus Hamiltonian. No, this is Planck's constant. So minus Planck's constant squared over 2m divided by 2. The negative of it. So the negative of that energy squared. So it's going to be. Okay, so if it takes oh god, it takes this much energy for Planck's constant, and then it's squared, so it's going to be slightly and negated, so it's going to be like this, right? I think. Wait, negative times a negative. Oh god, this is where I'm just the worst at maths. Negative 2 to the power of 2 equals negative 2. Nope. Negative 2, okay, to the power 2. It becomes positive. Okay, interesting. So this will be positive, and it'll just be like. I'm glad I checked that. It'll be like this. Wow, you can't see that. You can't see that. Let's try red. Just get a little bit steeper. To the power of 2. Yeah, yeah, that makes sense. Divided by 2m. So it says divided by 2 times whatever m is. I mean, let's guess it's mass. I don't know. Divided by, so it's going to come down a little bit. So maybe it might come down here. Let's just guess. And then this might also operate on the x-axis rather than the y-axis. But anyway, let's just go with the flow. And you're multiplying this by the change of the wave function. I've no idea how to express that over x squared. So it's some kind of area thing is equal to the imaginary number times Planck's constant. Imaginary number times Planck's constant times a change in the wave function over time. Right, okay, fine. I feel like that is the actual. I feel like that is it, but let me just double check my notes here. That does look. It looks familiar. It looks familiar. Let's see what we got here. Yeah, so we've got. That was lucky page open. That one there. So yeah, that's this the imaginary number part. Okay, fair enough. That's cool. Let's put that down for now because I'm pretty sure I've been through this before. So let's finish this one off. I of h, and it's going to be the change change in the wave over the change in time. Or was it squared? This squared, I think. No, it's not. No, it's just that. Change it. Okay. Because it's not a second derivative. I guess that's what that means. I don't know. Who knows? I don't. Okay, cool. So we've got Schrodinger's equation. And it says, Schrodinger's model allowed the electron to occupy three-dimensional space. Allowed the electron to occupy three-dimensional space. Okay, cool. So in this case, let me just delete this. This is pants. So we are looking at, wow, I hate OneNote. It's not great. It's not great because I've lost my ability to scroll now. Okay. Now it's back. Okay. So this is going to go into three-dimensional space. There is a position somewhere. Let's call this point P1. And this is the thing you can't even see because I'm an idiot. Let's try green instead. Oh yeah, that's a bit better. And we'll do that. Oops. Down here. And let's do that. Whoa, wow. Okay, cool. Just to kind of build up some kind of patterns in my head to remember this. It therefore required three coordinates, or three quantum numbers, to describe the orbitals in which electrons can be found. So, if they're talking about orbitals, we are literally talking about this kind of thing. Well, I suppose I'll just draw like this. And then maybe I'll draw one like this. And of course, this is working on this kind of grid, so something like that. So you see, this is kind of coming out into the X. Coming out into the X. It therefore required three coordinates. Well, okay, out into the Z. Sorry, I'm thinking of my engine there. It therefore required three coordinates or three quantum numbers to describe the orbitals in which electrons can be found. So this is three quantum numbers to describe a probability of any position on that three-dimensional space. That makes sense, right? If you can't just express a probability of a position, it needs to be a probability of position in a coordinate system. So three coordinates that come from Schrodinger's wave equation are the principal n. So you've got n, and we've got this is the principal. This is the principal. Okay, and then we've got L, which is the angular. Okay. And the magnetic. Wow, okay. Magnetic's throwing me off. I don't know what. The magnetic. Electromagnetic force, maybe. I don't know. It doesn't sound right. Magnetic. Let's hope it explains it. Describes. Let's go. This describes a probability of position in a three-dimensional coordinate system. Euclidean, essentially, I guess. I'm guessing that it doesn't say that yet. The principal quantum number, n, describes the size of the orbit. Ah, And let me just define principle. See if I can get some intuition here as well. Principal. First in order of importance. Oh, that's interesting. So you scale something first, then you rotate it, then you translate it. Noting an original sum invested, I'm just thinking out loud here, trying to think of why I've called it this. A sum of money lent or invested on which interest is paid. Principal. First in order of importance. Interesting, so the scale. Okay, so let's go into more detail here. Is there any more colours? I want more colours. Pink, ooh, pink's good. So let's go here. N is equal to, or describes, yeah, is equal to, no, describes size of orbit. Now I wonder if that's in radius of orbit. Orbitals for which n equals 2 are larger than those for which n equals 1. Orbits for which n equals 2 are larger than those for which n equals 1. That makes sense. For example, because they have opposite electrical charges, wait, what? The principal quantum number n describes the size of the orbital. Orbitals for which n equals 2 are larger than those for which n equals 1. Okay, for example, okay, because they have opposite electrical charges, electrons are attracted to the nucleus of the atom. Oh, okay, fine. Read the rest of the sentence, I guess. So I think it's just simply saying, just mainly for myself, really. If I look back at this video, sometimes I watch them. I think it's just simply saying, here's your nucleus, here's your orbital, here's your second orbital, and orbitals for which n equals 2, and orbitals for which n equals 1. Let's do this over here. This one and this one. And it's just saying, because they have opposite electrical charges, electrons are attracted to the nucleus of the atom. Of course, because the nucleus is made up of protons and neutrons, and protons are positively charged, and these are electrons, and they are negatively charged. I think that's all that's saying. I think, and thus of course they attract each other, right? That makes a lot of sense, I think. In we go. Okay, so energy must therefore be absorbed to excite an electron from an orbital in which the electron is close to the nucleus. So n equals 1 into an orbital in which it is further from the nucleus. So what it's saying, I think, is, let's see what other colours we've got here. Ooh, orange. Orange is nice. In order to go from, let's say this is the nucleus, and this is, let's go back to that nice blue. I really like that blue now. This is electron 1 on n equals 2, and this is electron 2, okay, doesn't matter, on n equals 1, right? And it's just simply saying that it needs energy to jump to n equals 2, and so electron of n equals 1 needs energy to translate to n equals 2. Cool, good so far. How are we going? Who's watching? No one. Great. So lonely. Okay. Now it says the principal quantum number therefore indirectly describes the energy of an orbital. I see, because n equals 2 is r away, or d away. Let's say d, or is at least r r equals equals nucleus plus n1, and then so n2 of r is equal to r plus n2 yeah, n it's going weird. I can't undo. All my undo's gone. I just don't understand this program. I really don't. R plus n2 minus n1. So we described here that the position, or the shell, or the orbital describes the energy because it is further away from the nucleus, or is closest to the nucleus, and thus the energy to move to the further away, it needs energy to get there. Because there is a significant pull of the electron to the nucleus, the protons. The angular quantum number, so this is the principal quantum number, okay? The angular quantum number, L, describes the shape of the orbital. It's amazing. The shape of the orbital, okay. So, one note, what are you doing to me? Let's go over here. So let's say that this is the principal, and here is the angular. The angular quantum number describe L n something like that maybe, describes the shape of the orbital. Orbitals have shapes that are best described as spherical, polar, or cloverleaf. Interesting. Really? Yeah, I wouldn't have intuitively thought that. It just doesn't. No, it does make some sense. Like, if you were to think of it from a magnetic point of view, so if you talk about a magnet of the Earth, right, you've got this kind of you've got these kind of things happening like this, right? I suppose in that case, I mean, such a model does kind of make sense, right? It's got all this room to move this, and all this room to move, and there's some probability that it will be somewhere here. So I suppose a polar does make sense. Polar, for example, does make sense if you think about magnetism of the Earth. I think there's some coming out here as well, but anyway. And then this 4 one is very interesting. It's like, yeah, how can we describe that one? It's as if well, what is the intuition for that? Aye. And they've called this one is D. Dipolar, two polar, maybe. No one knows. I don't know. I'm just joking. Why would it do that? Let's see. I wonder if maybe if it starts, it's kind of, let's take this nucleus. Maybe if it goes around and is pulled back in, then it's going to shoot off that way. So it will go around and it will shoot. It will be pulled back in, and when it gets pulled back in, it's going to go that way. But you think, well, I mean, does it go back through that? And it will just keep going around like that, and around like that. I mean, that's an intuition, I guess. Intuition's bullshit, but let's just go with that. So they can take on more complex shapes as the value of the angular quantum number becomes larger. So as L becomes, well, you know what? I fancy an orange. As L becomes larger, the shape becomes more complex. Interesting. What is that saying? As L becomes larger, the shape becomes more complex. L because we are not describing energy here, because the principle describes the energy. So you would say that if the shape of the orbital, so it's merely saying, what is that saying? It is saying as the shape spherical L, polar L1, or cloverleaf L2. Oh, I see. Okay. As they become more complex, as L becomes bigger, from a range of L equals 0 to 2, then of course the larger number, the more complex, because L is a cloverleaf, L1 is a polar at 1 and 0. Okay, I see. Cool. This is a great drawing. I love this so much. Let me also actually just document that here. This is a great drawing. I love it. Okay. Let's pan this up a bit. There is only one way in which a sphere, L equals 0, can be oriented in space. Yes, of course. If it's a sphere, and we are not talking two-dimensional, we're talking three-dimensional. This is a sphere, right? So if you try to orientate it, well, I suppose the point here to make is, although we can say that the sphere, and I'll just put a kind of like some kind of this contouring here to represent that. Let's say its center is here, and even if like it breaks through the surface here, and this is the remaining part of that, even this is pointing towards, I know, 0, or it's pointing towards x, y, and z, and anything else would be x plus n, or y plus n, or z plus n, then this is saying that only one way in which a sphere can be oriented in space. So orientation. Let's find this. I don't think this is to do with translation. So I think the action of orienting someone or something relative to the points of a compass or other specified positions. So that's interesting that they've said that, because actually I mean, perhaps I explicitly disagree with that, but maybe I intuitively know what they're trying to say. Because of course, if I were to rotate my sphere to here, for example, it would start to come out here. This is x, x, x plus this vector of v, right? So and so on and so forth. This is very different. So I'm not sure I kind of feel that intuition. There is any way in which L. So it's saying though that there is only one way in which a sphere L equals 0 can be oriented in space. Orbitals that have polar L equals 1 or cloverleaf L equals 2 shapes, however, can point in different directions. So it is saying that there is an explicit gauge in which, sorry to redraw that, in which y, x, y, and z is its definitive orientation. That doesn't make too much sense to me. Okay, but however, L1 and L2, they can be differently oriented. Interesting. I suppose this is super abstract. We're trying to think here, so excuse me. So I think this makes sense though, because if you have this obviously and this, then it can, of course, it can be moved by v and become this one. All right, and so on and so forth. We therefore need a third quantum number known as the magnetic quantum number, m, to describe the orientation in space of a particular orbital. So even though s equals 0 does not need m, s equals 1 or 2 does need m to define orientation. Okay. Okie dokie dokie. Great. Cool. I like it. I don't get the s equals 0 one, to be honest. Just a fact of the world, I guess. So I'm just going to keep it that way for now. It is called the magnetic quantum number because the effect of different orientations of orbitals was first absorbed in the presence of a magnetic field. Wow, so it is a experimental conclusion there. Okay, amazing. Let me also just whack this bad boy into here. Great. We'll scroll back down again. Okay. Rules governing the allowed combinations of quantum numbers. Three quantum numbers, n, l, and m, that describe an orbital are integers, 0, 1, 2, 3, and so on. The principal quantum number n cannot be 0, so the n, which is the scale, the size, cannot be 0. N, okay, well that's a great point, so let's go back to that. N cannot equal 0. Cannot equal 0 because 0 implies it does not exist. Okay. The allowed values of n are therefore 1, 2, 3, 4, and so on. So the three quantum numbers n, l, and m that describe an orbital are integers. The angular quantum number L, which describes, yeah, okay, so it's the angular one, right? Yeah, this is the orientation thing. No, it's not. L was the shape. Can be any integer between 0 and n minus 1. Um, okay, because um, because we are stuck on base 0 here. So if you want to have this 0 to n, then you've got an additional point that doesn't make sense. Just to explain that, I think that's what it means. Just a bit like programming. If you were to say n equals 0 and there are 3 elements in your array, then you would have now 1 and 2, which makes a sum of 4 numbers. And 4 does not give confidence in the number 3 that we supply, so we need to do n minus 1, in which it gives us 3 numbers. I think that's what that means. For example, L can be either 0, 1, or 2, and the magnetic quantum number can be any integer between minus L. So the M, let me just, how do I redo? Cool. So M can be between minus L and plus L. If L equals 2, M can either be minus 2, minus 1, 0, 1, or 2. Okay, and M is correlated to the shape, but implies orientation. So, in conclusion, N, L, and M are all real. I mean, what is the mathematical symbol for integer? Is the symbol used to represent integers? Oh, okay. That's interesting. I didn't know that. Is it a special Z? I imagine. As important as this is. The letter Z. Okay. Z. Are all Z. Z is integers, yeah. I'm interested to know the Z. I can't help but think it's gonna. Yes, I knew it was that. Ah, I knew it was that one. So it's this little special kind of sexy double zig here. Are integers. Okay, cool. Good to know. Let's go back to our thing. Practice problem 7. Describe the allowed combinations of the n, l, and m quantum numbers when n equals 3. Well, that's a good question. I'll just do one of these. If n equals 3, then L can be n 0 to n minus 1, so it's 0 to 2, which is, let's have a look, and then, okay, well, I'll do this first then. So then L, n equals 3, and so m can be minus 2 to, let's do arrows. two arrows, to plus 2. Let's make sure I got that right. I might have forgotten this already. So it says L can be an integer between 0 and n minus 1. Great, 0, n minus 1. And the m is of course the negative and positive of L, where L is going to be 2 and not n. Awesome, picked it up. So that's really interesting. That's the way that describes it, and this is apparently in Schrodinger's equation. So I suppose I'm kind of interested to see where we've got this m. Nothing else. So we have to derive this a bit maybe. Oh, this is in one dimension. Second derivative with respect to x. Showing a wave function. 8 pi, what is that? That is 8 times spin. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 squared. Or is this another differential? No, because it would be the d. Squared times the orbital orientation. So 8 pi squared multiplied by a direction divided by h squared, and I'm guessing this is Planck's constant because it doesn't mention anything here. I mean maybe if I zoom into this image it'll be a bit more clear. Let's try. No, it is just h. Now, that's interesting. I wonder what h stands for. Hmm. Not sure. Well, okay, let's imagine it is Planck's constant. Let's imagine that. Plus the change of the wave function on the one dimension x position. Multiplied by the energy, which is going to be the energy is going to be L, because that's the scale, minus the potential energy. That is the kind of summary of the atom, I guess. Like the electrons and protons in it will be the potential energy, and the energy of that given system or transaction would be E, and then multiplied by the wave function itself. Huh. Don't understand it. Interesting though, nonetheless. Orbitals that have the same value of the principal quantum number form a shell. Orbitals that have the same value of the principal quantum number form a shell. So the principal quantum number, the scale, let's go down here, new section. The orbitals that have the same value of the principal quantum number form a shell. So if the L is equal to the principal was n, wasn't it? Principal is n, yeah. So if n is equal to L, orbitals L, if n is equal to L, then this will equal a orbitals within a shell form a shell. So this is going to be the nucleus, and this is the shell, and this equals this. I'd like to see the numbers actually around those. I'm looking forward to it. Orbitals within the shell are divided into subshells that have the same value of the angular quantum number. So, let me just... That's very tasty. Same value of the angular quantum number. How does that work? Because it's saying orbitals within a shell are divided into subshells. Orbitals within a shell are divided into subshells that have the same value of the angular quantum number. The angular quantum number being the size. That's what that was. Because as L becomes larger, the shape becomes more complex. No, L is the shape. I see. N describes the size of the orbit. Angular is L. That is the shape. And M was the orientation. So, as N, as the size becomes equal to the shape, as the size integer becomes equal to the shape, orbitals within a shell this is just a different sentence. Orbitals within the shell are divided into subshells that have the same value of the angular quantum number. So the angular quantum number is the L, so that is the shape, and the subshells same value. I wonder what value means in this case. So chemists describe the shell and subshell in which an orbital belongs with a 2-character code such as 2p or 4f. The first character indicates the shell. Yep. The second character identifies the subshell. By convention, the following lowercase letters are used to indicate different subshells. So, well, we learn, this is funny how we come back to what we learned 2 days ago, but if this is the nucleus, we have shell 1, which is S or 1s. This is 1s, and then we learnt that this will be 2s. Now, this is saying, although there is no pattern, so this is the second character identifies a subshell. By convention, the following lowercase letters are used to indicate different subshells. P, D, and F, where P is the, this does say up here, I can't remember now. P is a polar. Oh, L equals what I see, and cloverleaf is L equals 2, yeah, and D was that. And you've got F. We didn't see an F yet. Okay, so although there is no pattern in the first 4 letters, S, P, D, F, the letters progress alphabetically from that point, G, H, and so on. Okay, some of the allowed combinations of the N and L quantum numbers are shown in the figure below. Okay. N equals 8. It's funny because it says, oh no, it says N can be 1, 2, 3, and so on, I see. Okay. Okay. So, okay, yeah, 7p, L equals 1, n equals 7. 7p is a different subshell. Combinations of the n and l quantum numbers are shown in the figure below. I don't get that. I'm going to come back to that. Let me just make a note of that. So we're going to come back to this. Come back to this. Cool. The third rule limiting allowed combination. The third rule limiting allowed combinations of the n, l, and m quantum numbers has an important consequence. It forces the number of subshells in a shell to be equal to the principal quantum number for the shell. The n equals 3 shell, for example, contains 3 subshells, 3s, 3p, and 3 orbitals. Okay. Right, I've lost track here, so I think what I'm going to do, I need to spend time on this. What I'm going to do is I'm going to make a leave here, and so we've got the Chemed thing here. This is important. This is exactly what I needed. And what we'll do is we'll have a little look at Python. That's what we'll do. Yeah. Okay, so how long have I been streaming for? Let's just see. An hour and 2 minutes. That's fine. Okay, cool. Yeah. Good place to stop. So I did have a little start with another project, but I actually need to get this working specifically for for the challenges of science. So let's open a new Visual Studio, or a new folder actually. Let's go. You can't see this, but I'm just going to do this off screen. Let's see, documents. Where shall I put it? Documents? No, it's not going to let me do it here. This one? Nope. Where are my Python projects? I have no idea. Not a clue. Found you, okay. So I will make a new one, and I'm going to call it, I'm going to call this ML for machine learning, right? Because this is going to be used for that. Let's go in here, and we will open this up in code, and let's get started on trying to get a project going. So I think first things first, if we create a main.py, we need to also instantiate an environment. So how do you do that again? It is virtual environment, and you give it a name, Python, and we've got to create the folder as well. I think that's it, maybe. Yeah, that was it. Okay, and then we have to activate it. So Python virtual environment scripts activate. Okay, what's wrong there? Okay, Okay, because I need to run the script. I'm not trying to Python it. Okay, makes sense. I'm now in the virtual environment. That's great. So if I go and install some stuff, what do we need? We need PySide 6. So let me go new file and we'll do requirements.txt. I'm going to put this PySide 6. I think that's what it's called. It's pip install, or maybe requirements.txt. No, I can't remember this one, so let me just Google that. Install pip requirements.txt. Oh, it is pip install. Pip install -r requirements.txt. Right, maybe, or read. You are using pip version 20, however version 21.24 is available. You should consider upgrading. Let's do that. Using this. Let's try that again. Yeah. And the pip install, I don't think that actually worked. Yeah, because PySide's not in here, and unless it gets put in here, it doesn't. Unless include, does it? No, it's not. So that's all updated. So what went wrong with this? Example of requirements.txt, and also want PySide 6. PySide 6 is it's Qt. Qt was, I think, developed by Nokia at some point. And PySide is their like open source version of it. That's what it is. PySide 6. Yeah, I did do that right. Okay. And so requirements.txt. Yeah, that should work. So why is that not working? Pip install -r requirements.txt pip install -r requirements.txt. If we run that, it doesn't do anything, and I certainly don't see PySide here. PySide 6 install. So upon installing each package one by one after installing PySide, I learned PySide 6 starts to fail and show the error after I do conda install matplotlib. I wonder, like, let's just try something like that. Matplotlib. What is going on here? Matplotlib. Now that is interesting. So now it's installing it. So does PySide 6 need that stuff then? Oh, that is so interesting. Yeah, I don't know what was wrong with that. Don't even see that it hasn't even done matplotlib. I wonder if I delete that, what happens now? Requirement already satisfied. Shiboken. Yep, no idea. Okay, well that's weird. But we got it. So now we've got that, we should open up Qt. I don't know how it works. Qt Creator, maybe? Maybe? I thought it was called Qt Designer, actually. Let's see. File, new, file project. We want a window. Qt Quick, Qt for Python, window. Choose. Present application creates a Qt for Python application that contains an empty window. Oh, okay. Well, I don't think I want that. I want a designer. Edit. File. Designer. Oh, that's the one. There it is. 612. So what is the Qt Designer? What's the new version? Qt 5.15. So somehow I've got some. Well, that's so strange. Alright, well. Oh, great. Okay, anyway. So this is what I wanted. Let's create a window. And well, I suppose we should try and connect up a button. Or maybe we should think about the kind of tools that we might want. We want to have like a way of drawing graphs. We want a way of doing like viewing matrices and maybe going through them step by step. We'll certainly want to see graphs though. I think graphs might be the most important one to do. So let's see if there's a graph thing. I don't think there is. There's not. Let's see what graphing tools there is. Mat, plot, lib, Python, graph, Qt, designer. Oh, I didn't mean to do it on this one. Let me just go back to Firefox. Yeah. Plotting matplotlib figure inside Q widget. Found the solution. Q widget. Okay, so we need a Q widget. There it is. Cool. We'll call this chart. Or graph. Graph, yeah. Okay, but let's imagine we want multiple graphs, so we need a way of choosing which graph we've got. So we probably want a kind of list of operations that we can do. We could even do a tabs, but the tabs kind of get a bit unwieldy, so maybe a list down the side, like a navigation menu. So let's do a vertical layout. And a list view inside that. Yeah. Okay. And we also want some grid as well, so we'll lay them out horizontally. Just have to resize this a bit, unfortunately. If I can, will you let me resize? No. Let's delete that for a sec then. Delete that. Fair enough. Fair enough, let's try that again. Huh. Widget. Central widget. the hell is a excuse me, central widget? Delete. Central widget has nothing until you put. Okay, let me just start this again because I think I lost track of what I was doing there. Let's create that. Discard. Okay, so we have a central widget by default. We're going to whack a widget in there, and then the central widget allows us to do this gridding. So now the what? Let's see, vertical panel. Let's go here. Okay. And then this will be a vertical panel as well. So the central widget, it's got this, and then it's going to have this one is going to be on the side here, and this widget is going to go inside that one. Okay, cool. So now we want to kind of squeeze it out to the left. Also, we want to probably a vertical line here, so let's do that. Yeah, maybe move that down. Can we do that? No. Interesting. Alright, well, okay. I can't size that at all, so I suppose, because we've got a widget now, maybe we want a label, say which screen we're on. Oof. Yeah. There. Okay. I want this kind of. Let's see if we can align this up to the top. Yeah, maybe just the height actually. Maximum size. That might be a problem. So let's give that. Well, I mean it should be automatic. So let's just say. Let's say this is the current or was page title, right? And this is the page current page, or yeah, current page title, and this is going to be labels in here. So we'll sort this page 1 label, menu label. Well, actually, we don't need labels. That's a silly idea. Let's change that to a button. Tool button, radio button, dialer, command link button. I guess it's that one. Let's do another one there. Okay, great. Let's call this a page 1 button. And in fact, I think I'd like to. Yeah, okay. Page 1 button. This will be page 2 button. Okay. And in fact, before this crashes, let's go and get this and plug it into there. We're going to put this into a folder called Qt. This will be Windows. Yeah, and then we'll call this, I don't know, main window, something like that. How about that? Okay. Okay. And that's fine and everything. I wonder. Don't know what that does. Because if we click, then I need to say load another entire pane, and I wonder if that pane should be a new window or a new widget. So it's going to be a widget, isn't it? Yeah, that is exactly it. And that widget is going to be plopped into here. Yeah, that's it. So it's not this one that needs so this current page is going to be a page widget, Windows widgets, and this will be a page one widget. Yeah, okay, and then in this one I'll put just a label for now, I guess. Well, actually, maybe a widget, which will be given the vertical layout, and then we'll do a label. We'll call this one page one. No, label, but that should say page one to tell us we've got the right one. Page one. Okay, and then we're going to do another one. This is interesting. Maybe I do that. Okay. Yes. Page one. And here's another widget, and this will be page two. I hope I'm doing this right. Widget, grid, widget gets filled. Let's have a label, and then this goes up to the top, and this will be called page two. This will be called page two. Okay. There we go. And these can go in there. Now, here's the thing. Oh, that's interesting. So it doesn't need to be. Okay, that's good. Fine. Let's do that for now. Yeah. And we'll put that as a page. And then this will be maybe a line, maybe a horizontal line. Yeah, okay. Fine, and how do we get these to kind of snap up to each other? Layout direction left to right. Abstract button, Q brush button, Q widget, geometry size policy, size increment, base size, cursor, mouse tracking. What's this say? Break layout. Edit widget, signals, buddies, tab order. Actually, I don't know what layout alignment. No vertical alignment. Top. It's not that. No vertical alignment. Layout. Morph into. Need a bit of help here. Qt make buttons in list view line to top. No. Just going to do a quick blood test. I'm being diabetic and I just feel a bit tingly, so I wonder if I am a bit high. let me see if anyone's also watching. No one's watching. Okay. If you were watching, then I would have explained why I'm doing this, but you're not, so you could just watch the video if you want to. Cool. Oh, blood sugars are perfect. That's awesome. All right, cool. Okay, so I mean, I know it's a bit of a designery thing, but I feel like if I can't get the design right, then I might be doing it wrong, and then I'll start coding and I'll regret it. So, is the goal to to actually get this aligned right? Widget qt widget qt list view vertical list layout line top. How to vertically align widgets to the top instead of the center. Use set alignment Q method. Set alignment. So this could be that one. There's nothing there for that. Q layout. The layout should be set alignment methods. This gives enough information for start. Okay. If you have a Q box layout and you want your fixed size widget to be stacked at the top, you can simply append a vertical stretch at the end. Add stretch. Ah. Oh, did not mean to do that. Stretch. Okay, that's not a thing. Vertical slider. No. Display widgets. List widget. Did I do that? Oh, you see, I haven't done that. I need a list widget. Let's do that instead. Yeah, and then put those in. Yeah, that's the one. That's what we wanted. What is this now? This is a list widget. Oh, I haven't done it right. Can I put those in there? No, I can't. List widget. Edit items. Add. Page 1 button. Properties. That really should be just a list. So what else have we got here? Table, group, scroll. This should be a scrolling area too. So this will need to go scroll area. Let's delete that there. Let's go back to this and get a scroll area to the correct place this time. Can I put it into here? No. Yes, I can. Great. So now I've got a scroll area. What is this? Scroll area widget contents. Can I move that in there? Maybe. There. Scroll area contents. I guess there should be a scroll. I see. Okay. I see. So let's just do this again. So we got a vertical layout of a scroll bar which has a vertical layout in it. Set maximum size, default constraint, layout stretch. What have we got in here? Nope. I wonder if this can be scrollable. It can't be. Don't think I've done this right. Although vertical layout sounds right, I wonder if it's grid layout, form layout, horizontal, vertical spacer. Okay, let's undo a couple here, because maybe, perhaps that's what they're talking about. It is. It is what they're talking about. Okie dokie, that's kind of helpful. Page 2 button. Page 2 button. Page 1 button. Put that there, okay, right. Okay, cool. Good. Good stuff. Okay. So I wonder if I can load those in. So let's see here. Let's take this view Python code. What we got here? Let's do this one first. Form view Python code. Let's copy that. In fact, is there a way to? There might be a way to do this a bit quicker as well. Convert UI into Python file Qt designer. UIC bat -x filename.ui to Python. Yeah, that's the one. So it's -x. So let's give that a try. So if I got my, let's see, there should be some Windows stuff in here. So what the hell is that? Oh, where did I put? Oh, there we go, Qt. Great. So Windows, and I should be able to go. Let's see. Open an integrated terminal. In fact, what I need to do is go here. UIC, that's the one. UI converter. It's going to be that, isn't it? So if I go .vmv / scripts. Ooh, I did not mean to do that. Whoa, I did not mean to do that. Cancel, cancel, cancel. .vmv / scripts / PySide 6 hyphen UIC X. So we're going to have Qt Windows main window.ui is going to become oh yeah, that's right. Output is going to be Qt. Let's call this let's make a new folder called models. This will be Windows, and then we'll go models Windows main window.py. PySide UIC is not recognized as the name of a command, function, script file, or operable program. Check the spelling of the name, or if a path is included, verify that the path is correct and try again. Might need that. Okay. .bat. Oh, now that's interesting. It does say .bat there. Okay, let's open this up in File Explorer, Windows, no, ML, VMV scripts. Is there a batch file here? Only activate. So this really is executable. So I should be able to run that. And but I'm in Qt. That's why that's not working. So can I copy this? Oh, I didn't mean to do that. Let's copy this. That's why it's not working. Okay. So I knew I had to do this at some point. It's not very um, medical, but has to be done to help me. So I'm kind of enjoying it anyway. Let's go back up to the root here and try get a terminal going. How do I do that? I want a terminal here. Where are we now? ML, that's the one we wanted. Let's try that. So I'm going to remove that dot back because like I said, .xe. Oh yeah. And then unknown option X. So let's try, what's PySide 06 need? It needs yeah, completely different from what they've said. It's going to be the UI to the Python file. Let's see what that makes. Yes, that worked. Okay, great. What we got? Ah, yes, wonderful. That'll be much easier. Let's save that script. We'll put that into like a README file. readme.md, and we'll just save that script there like that, and run that on the widgets as well. So widgets. Let's see if we can do that, and we're going to do a page one widget, and we're going to do that here. Let's see, widgets dot page one widget. Qt could not find a path. Models widgets page one widget dot py. Yeah, I suppose that makes sense. Maybe I do have to make a folder for it. Let's try that now. Yeah, it needs the folder. All right. Yeah, great. I wonder if I zoom in. Can I zoom in? Yeah, I can. There you go. That's better for you. I'm so sorry, guys. Yeah, this is much better for you. Page 2, and then I'll do. Oh, I know I fucked this up now. Try it again. Page 2 and page 2. Cool. So let's see what's actually being created here. Excuse me. UI form. And UI form. This is not acceptable. Why is it not being called something decent? Do I have to name it somehow? UI form is not going to cut it. Not going to cut it at all. Form settings. Edit. Settings, preferences. Oh, well this isn't helpful. Object name, form. Okay, oops, that page 1 widget. Let's try that. Try running that one again. Yes, that was it. Okay, great. So actually, capital names are all the way. Let's try that then. Great stuff. Page 2 widget. And then this will be a main window. That's fine, that's already named correctly. Okay. Don't think that page 2 liked me there. What have I done wrong here? Yeah, okay, haha. Wrong one. This one. Page 2. Page 2. Okay. So anyone's joined me? No one's joined me? Okay. Great, so I've got two classes. I've got a main window. I've got a place to whack that thing. So it's going to be current page. So I need to start this all up. Now, not that I can remember how to do this, but let's say we have an app Yeah, let's do that. So we've got maybe a kind of a just a very generic file here, class app, and we'll say run, define run, and this will be an instance, so we'll have that. In fact, let's see, why does this not give me type ahead? Extensions, Python, IntelliSense, Pylance, yeah, that sounds good. Python for Visual Code, Pylance. So this is already on IntelliSense. Extension settings. Let's see. Python IntelliSense for Visual Code. Visual Cod. Python and Visual Studio Code. Python Hello World tutorial. Extension. The tutorial guides you through installing Python. Let me just uninstall this. Let's get some of these off of here. Python. Reload required. Yeah, okay. So now if I go to here, go to my app, what does it come up with? Yeah, I've installed the remote WSL extension, but I have not used it yet. To start, open a new WSL window. No. And I want Python. Self separately from the extensions. For a quick install, use Python from python.org. Once you have a version of Python installed, activate from the select interpreter command if VS Code doesn't blah blah blah. You can configure the Python extension through settings. So let me see. Is Python still running now, or I just buggered that up? No, it's good. Yeah, autocomplete says the Python extension supports code completion and IntelliSense using the currently selected interpreter. IntelliSense is a general term for a number of features, including intelligent code completion. IntelliSense quickly shows. So this should already have something. There is something here, but I don't think like it's not helping me with. Because if I do as, well, fair enough. Return. Let's see if I do an int. If I do an as. Let's see as, and then as dot. What are we going to get? No, it's not helping. Add test. As test. It's just all over the shot here. Well, that's not helpful. Because this should tell me that, I mean, let's see what we get back. There is no type ahead here, so let's do this properly then. Working with Python using the Microsoft Python extension is simple and fun. Microsoft Python. Microsoft Python. Microsoft Python, where are you? Install linting. Install. Yeah. There it is. Oh, it is the Pylance. Well, it wasn't working, but okay. Try this again. Just trying to get type ahead, so this gives me type ahead now. Ah! That looks better. Why have we got squiggles here though? Yeah, okay. pass. So if we do app, sorry, as dot we got nothing coming back. Return 1. Now here is an app. There's two methods there, so that should know what I want to do. Because that is definitely there, right? Like that's not going to fail. Let's try this again. Define run. Def. Oh dear, I don't like this at all. Don't like this at all. Configure the debugger through the debug activity bar. Configure a test by installed extensions. The Python extension will automatically install the Pylons and Jupyter extensions to give you the best experience when working with Python files and Jupyter books. However, Pylons is an optional dependency, meaning the Python extension will remain fully functional if it fails to be installed. Let's see if someone's had this problem. So, Python IntelliSense not working in Visual Code. Language says may not be running. Try restarting VS Code and this should solve the issue. Let's try that. Let's give it the benefit of the doubt. Open with code. Are you helping me now? No, you're not. Are you helping me now? No, you're not. Oh, that's my fault. That's why. That's gonna work now, isn't it? Yeah, works. Yeah, great. Alright, and what does this do though? Self. Doesn't give me... Fair enough. That is fine. Okay, good. Good stuff. We're getting there. So, we have an app and we want to run that app. Now that app is going to be a Qt thing, so what do I need to do? I need to show the main window. That means I need a UI main window. I need to call this setup UI, or do I? Probably don't need to. Let's see what happens. So my app has a main window and it is of type UI main window, and in the constructor it does do type ahead. Fantastic. Main window equals a new main window. Yes, please. It's going to be self, and then we'll have a self dot main window dot show. Now I don't know what this has got in it, so let's have a look. Setup UI, retranslate, but it comes from an object. This doesn't seem right, so I think I need show Qt window Python. What have we got? set central widget, clicked. So you put the Q main window, here it is. Q main window, Q application. Yeah, first. So if I do, oh, that's so strange. I wonder if I need to, If I pull that out into here then, move, and put this into here, and this into here, and I make a new folder called main window dot py, and if I have a class of main window, and this inherits from both my my UI main window, which I'll inherit from source action, binary references peak, sort imports, source action, sort imports, no. Well, I suppose I want that, so it's going to be import qt.windows.main window. From that import main UI main window, right? Yeah. So I suppose that should be now. UI main window is not defined. That's correct, it's not. Ah, that's why it wasn't working before. So if I do that again, let's see if it source action sort imports, no. How do I get that? Add. Ah, there it is. Okay, great stuff. And AutoPep is not installed. Yeah, sure, why not? What is it going to do for me? Sure. Great, okay, good stuff. So that is going to inherit from that, but we need to inherit from qtgui dot qmain window. And then this will need to have, let's see, initialization. It's called the super initialization. That's great. Yes. And then we'll have a well, I almost want a main window, like a base window, don't I really? Poi. Let's do that. And then we'd have a class base window, and we're gonna inherit from qt underscore, can't remember, this one. Essentially it's gonna be that, actually. Base window. This will be an abstract. This has to inherit from an abstract class. Although I'm not sure. Hyphen abstract class. Let's see. ABC, maybe it's lowercase. It's uppercase. Why are you not coming then? From ABC, do I need to do that in requirements? Maybe. C, so going to be Python install r requirements dot text. Requirements dot text. Requirements dot text. That's correct. I'm not inside anything. Yeah. Py install. No such file or directory. I guess it's a hyphen. Ah, I'm an idiot. Pip. That's going to be install now. Pip install. Couldn't find a version that satisfies the requirement ABC. ABC meta maybe. A helper class that has ABC meta as its meta class. With this class, an abstract base class can be created by simply deriving from ABC. Note that the type of ABC is still ABC meta, therefore inheriting from ABC requires the usual precautions regarding meta class usage. Huh? So is that not, that's not a thing, maybe the other one is though, so if I do ABC meta, that's the one. This is not defined, but I cannot define it. Well, okay, fine. I just don't know how to use this then. Abstract. Python. Abstract method. Abstract method. We're going to have a show, like, show self. We'll do nothing. Pass. And then this will inherit from ABC, but ABC doesn't exist. Ah. No. ABC. Inherit from, add from ABC. Add, import ABC. Ah. That's the one. Alright, okay, we've got it now. So, what does this say? Abstract method is not defined. Return 1. How does this work? Class method, abstract method is not defined. Add from that. Got it. Okay. Oi oi oi. Let's just do a pass. Okay, right. So if we've got a base window, let's make this inherit from that instead. And then let's see how we're going here. Yeah. Oh. I've been doing this for 2 hours now. Main window and let's see, we need a consistent method ordering pylons. Cannot create consistent method ordering. Not sure what that means. Although I do, that is different. Let's try that. Okay, interesting. Base window now, its UI window is doing what? UI main window is just inherited from an object, so base is from that. Ah, that's not right. That's the one. And so the show is abstract, but actually I don't think it is abstract. So let's just get rid of that and get rid of that now. I don't think we need that now. Well, I guess it is abstract in a sense. So yeah, let's do that. I just don't need that at the moment. Okay. And then our main window is, of course, going to do that. So then in here, we've got our new main window, which comes from, let's see, we don't need that anymore, because that's going to be our main window. And then run is going to show that window. Did that actually come up type ahead? Show. No, so let's see what we're doing wrong there. So they've got show here, so but main is first. versus that. So show is a thing, it's just not coming up as a type ahead. Interesting. Okay, and then I suppose my main application will be an app. That's going to be app. Oh, I need to do that. Add that. Then app dot run. Yeah, and then app is going to run, initialize, run that, show the main window. Let's give it a go. No module name models on app. No module named models. Source code string cannot contain null bytes. From main window import UI main window. Wait, let's just clear that. Try that again. Code string cannot contain null bytes. Ooh. This isn't even being used here, so that's useless. Run debug. That shouldn't be run like that, so let's try from here. Great. Has no attribute queue main window. Yeah, okay. Qt GUI queue main window. Qt GUI has no attribute queue main window. Ah, I need to do that as well. Which I did not do yet. App. It's going to be a queue application. And this will be resolved here. Self.app. Self.app equals sys.arg. Let's import that. Oh, I'm sure. Oh, that is interesting. Sys.exit. Sys is a thing. Self.app.execute. Sys is not defined. Import sys. Yeah, that's weird. I swear that should resolve that thing, because it doesn't know about it. Strange. Right, but how do I... Aha, maybe... So I never understand this part about Python is... Do I need this? I don't know. Let's give it a try anyway. So now we're going to run Python file. Has no attribute queue window. It really think it does. I guess not. Queue window. Let's try this one. The only thing I don't understand is if I can see it. If I can't see it, like why can I not see it? That makes a lot of sense. Hmm. So source code string cannot contain null bytes. That's what it means. For posterity, I had the same problem, fixed it by using file name. I'm using visual code. The encoding was set to. You can check the encoding. This message when I wanted to evaluate. Just encountered this problem, which is okay. Let me just try one thing here. So if I do, I know, we'll get rid of that, and then we'll print hi, and we'll comment this one out as well. Does this run? Ah, now that is interesting, because I am doing nothing here. Run debug Python file. That worked. Okay. So what works here then? It's about to fail now, isn't it? Source code string cannot yet from QTU my UI main window, and this isn't being used. Try that again. Yep, UI main window is there, class main window. Message appears when there's a null byte in the file. It doesn't say how exactly to remove it, but I try to edit. Let's try some of these formattings. I don't know. Don't know what I'm doing really. Play. Still got the same problem, and it's in this file. We formatted that file, so it's not that. Um, hmm. For the interpreter, I'm getting syntax error saying. Uh, hmm. I'm not sure what this means. This, though, has no init, and this doesn't matter, so nothing special about that. This is a base window that's inheriting from Q window. I wonder if that's a problem. Let me see if I can check some other code I've written before. Models, VMV data. Models, machine learning. Okay, maybe not there, so Python, files, models, windows, Q main window. Oh, that's interesting. And it's a widget, like that. That is interesting. Okay. So give that a try now. If I go back to my main and run this. Metaclass conflict. The metaclass of a derived class must be a non-strict subclass of the metaclass of all of its bases. So this one is imported from ABC, and my ABC metaclass of ABC. The module provides the infrastructure for designing abstract base classes, ABCs in Python, as outlined in PEP. See the PEP for the collections module has some concrete classes that derive from ABCs. These can, of course, be further derived in addition. The collective.abc submodule has some ABCs that can be used to test whether a class or instance provides a particular interface, for example if it's hashable or if it's a mapping. This module provides the metaclass ABC meta for defining ABCs and a helper class ABC to alternatively define ABCs through inheritance. A helper class that has ABC meta as its metaclass. With this class, an abstract base class can be created by simply deriving from ABC. An abstract base class can be derived, avoiding sometimes confusing metaclass usage, for example. Note that the type of ABC is still ABC meta, therefore inheriting from ABC requires the usual precautions regarding metaclass usage. As multiple inheritance may lead to metaclass conflicts, one may also define an abstract base class by passing the metaclass keyword and using ABC meta directly, for example. Sure. And let's just do that anyway. No problems there. Let's go back to this. Run this and see what it says. Subclass and metaclass of all its bases. Type error, metaclass conflicts. Let's try searching for that then. Let's see, it says import base window, class base window, Q window, metaclass, type error, metaclass conflict. The metaclass of a derived class must be a non-strict subclass of the metaclasses of all of its bases. Not had this before. Well, I suppose for now I don't really need it, so let's be a bit more rational. This is purely thinking ahead, so let's go for that. Let's see what error we got now. Python main.py says app.py main window equals that, and cool, and then source code string cannot null bytes from import UI main window. So this is mucking up. This is needing to inherit from that, so that's okay. Interesting. I wonder what this is trying to tell me. Let's see, did we get here? Let's just make sure of that. No module named models. Do I need to specify like a dot or something? Oh, not like that. Nope. And main window does come from there. Yeah. Run debug. Port main window. No module named models. Models is there. Models has got windows. It's got main window. And then we're importing the main window. So I guess this is failing. Base window. This is interesting. I wonder if we should not be calling the initialization def init. That'll be why. That'll do it. Okay, let's try that again. Option was not defined. Let's do that. Yeah, that's the one. That's the one. And let me do that with this as well, because now I'm def init. Yep. Yep. Let's try that now. Source code string cannot contain UI main window still. Main window is here. Here it's from that. So this main window comes from base window. And base window is this. And this is that. So that looks better now, at least. Okay. We're saying that if I pi.main is saying line file mainline in modules file from main window from Qt Windows main window import UI main window value error source code string cannot contain null bytes. I wonder if there's something wrong in here. Well, it looks all good. Setup UI. I mean, do I have to call that? Because it looks like it's like a runtime thing happening, so maybe after initialization, I don't know. Show setup. Was it self.setup UI? Like that? Ah, does that take a does that take a it does main window. So I don't think I want to be doing that then, because main window is coming from an internal. No, it's not. Setup UI for what? So if I call that, what happens? I wonder if I can do that. I wonder. Oh dear. Oh dear, oh dear, oh dear. Oh, whilst I'm here, I shouldn't forget this. So the app needs to also be configured slightly so that DPI is scaled correctly. Remember that one. What we got here? This opens that. Run is showing. Yep. And then, so I'm looking on my side because I have done something similar to this. It's slightly different, but trying to see if there's any hints as to what might be going wrong. Inherit main window from pi side 6. Q widget, this one. Yeah. Well, if yes, then your issues come from trying to access an attribute that is not yet created, which creates this attribute so it doesn't exist before you call this method. Well, I've got that because my so I do my main window and I know it up. Self and parent is an optional widget. I wonder as well what these inherit from object. Yep. So this actually needs a parent. My base. Okay, so this parent is optional. It's optional in array. Flags and none. Okay, so coming back to the start, I'm going to clear the screen, we're going to run it, and it says source code string cannot contain null bytes. Here's a thought. I wonder if there is something wrong with this main window, for example. If I do a kdiff3 and then go to here, Python, and copy this, let's see what's different. Nothing is different, so that's fine. Okay, that's good. So I can still use that technique. Yikes. Just gonna correct this whilst I'm here. Okay. Don't really know here. Don't really know what is going on. This should be done. App equals app.run, and the app running it, that should initialize this application. It should new up the main window. When newing up the main window, it goes here and it's like, hey, can I have the UI main window? But it's like not liking that. So if I stop and just make sure I've got the right thing, Qt Windows main window, right? And then Qt UI main window is just inherited from object and has nothing else going on. And the code seemed okay. So we come back here and base window. Inherits from this. And that allows it to be setting up UI, but actually, is this where I'm going wrong? Mm, I've got the wrong argument or something. I wonder, let me just try, I wonder if this is calling the wrong part. Something more a bit like this. And so that would also be here. And then we've got to run main. No, it doesn't like it. And you would expect it to be right anyway. Q widget. Window flags. Let's see, inherit from. Anyone watching? No. All good. Q main window. Main application window. PySide 6 compatibility Python. I wonder what version. Support for Qt6. Yeah. Python. What version of Python does PySide 6 support? PySide 6 supports Qt6. Python. Doesn't say. PySide depends on Qt4, which is no longer officially supported. All development efforts are now focused on PySide 2 and Qt5. According to this tracker, there are no plans for officially supporting PySide beyond 3.4, mainly due to lack of resources. Excuse me. When was this written? 18. Just trying to find the version that this supports of Python, because it might not support 3.9, so is that we support 3.9 and we've raised the minimum version to 3.6. Okay, well that should be good then. Okay. A source code string cannot contain null bytes. And it's coming from that. This is CRLF. Ah, look at that. ETF8. Nope. What was this? ETF8. Oh, I wonder if that is a problem. Oh, interestingly though, that has now solved that. So what is the other ones like? We've been coding ETF8. And then we've been coding ETF8. Now let's try it. Okay, module PySci6 has no attribute Q application. Not sure about that. Q application, maybe that's it. Let's see. I think I've got something here I can look at. So it'd be Qt widgets Q application. Like that. Okay, we're getting somewhere now. Missing two arguments, parent and flags. Missing two, say main window, app. Missing arguments, parent and flags. So here's the thing. I don't think I need those. If I do none and none, what say you? Right. Okay. Base window. Q main window. So if I put this variable amount of things in, I wonder how that's going to work. Is this going to work? Who knows? I don't think it'll work, but let's see. Argument 1 must be type, not main window. Like that. And like that. Oh, now that's interesting. Is that... Edit called wrong argument types. Qt widgets.q main window. Yeah. I see that. So that is no longer an option. Okay. Let's try this again. Def init. We're gonna have to do that. And I don't know what an optional is. Optional type is equivalent to union x none. Requires a single type. And then what's this? PySci Windows flags. Flags. Let's see what this does. Window flags example. widget or window, Qt window. Okay, so let's try that then. Put this back to how this was. So app is going to do that, and then this is going to do Qt dot flag. Flags equals Qt widgets dot flag window. So it is a default there. There's a default. So I don't need these. So what the hell is it going on about? It says missing two required position arguments, parents and flags. But at the main window, if I go through to that and then go through to the main window, now there is a parent, but this is optional, and this one was optional. Ah, but not in this sense. Because this is getting passed through. And then I guess if I go to here, no. If I go to here, then go to here, equals dot dot dot. That might be it. Equals dot dot dot. That might be the problem there. Main window. Yeah. Alright, so that's going to be found call wrong arguments in it. Found signature default flags window. This is done on the base window. Python inherit from Q widgets Q main window. That's interesting. Q main window takes an args in this case, but he is using, or she is using, Qt5. He, yeah. So. And it calls with wrong argument values. Found signature that equals none and equals default. Let's try that then. I don't know how this will work, but let's find out. Equals default. Default dict, that's not what I want. Qt core, nope. Oh man, this is so ridiculous. Def underscore init. I mean, you'd kind of like to trust that this is going to work, right? But if I run it now, it's not going to work. Missing two arguments, parent and flag. And so then I want to go into this and provide the right things. That means parent, who is optional, needs to be a Q widget. I mean, if I supply it with none, Q widget, self.app, flags any. none. And why does none not work? Bit stuck, to be honest. Parent equals none. Q main window. Pi size 6. Huh. Q main window is coming from where? Now that is really interesting. So it is saying that actually these like less explicit terms are fine and dandy. And so that's going to be this as well, but with base. And then now they're not calling that, so let's just knock that off for now. Need to do that. Clear screen, run and debug. And it says call with wrong argument types, init non-type, non-type. So what are the signatures of that? And it explicitly says this is optional, so def init should be fine, and main window should be fine. Unless maybe I forgot to do that. Oh, is that what I forgot? That's probably what I forgot. Main. J-A-I-I-I. Main windows. It's gonna have to have the defaults in there. So it's gonna have to have none. And this will be equals default Windows flags. And this needs what? Add from type default dict, but that's not what we want. That's not what we want either. We want Q window. Let's see what Python dot in def parameter. Three dots. Default secondary parameter is a singleton object. Essentially what's being done, okay, so with respect args is a rest parameter. It always has to be the last entry in the parameter list and it will be assigned in an array. Yeah, okay, so this is optional. That is what that means. And that base will be optional. I know they've done this before, but I must have missed something somewhere. Because that makes a lot of sense. essentially what's been done is put control it. The meaning of args is JavaScript spread operator. I don't understand. Where is it? How do you use it? Python method signature with ellipsis. With ellipsis. The ellipsis inside the brackets is indicating var arguments. The one outside just means here be the function implementation. So it's like pass, although I thought args or something was to indicate var. It's not actual Python code, just pseudocode showing how functions can be called. That means you could call this with more arguments as appropriate. Similarly, the ... in place of implementation means this is where the implementation is. This syntax is useful for documentation, but it's not a function of Python. With the actual signatures, note also the so maybe it is fuck. This is none. I have no idea what these are. Window flags. Python Qt window flags. And, let's do this again. And that again. Undo that, undo that. Go here, I'm getting really tired now. Main window. So on this, I'm going to do, hopefully we got access to Qt here. Oh, dot window, okay, great. And this will be none. Please work. Ah, great. We have a window. This is not my window, however. So something has gone wrong. That is not my window. Main window, self, self. Yeah. I wonder if it's, let's see, something like that. So this gets made now. This gets, no, this gets passed in. That then creates, let's just try this, UI main window, see what happens. It doesn't like the fact that that's a window and that should be a widget, so we're probably okay there. Ah, that's what it is. Now I've got to go and set it up. We've done it! Ah man, that was quite the struggle. Okay. Right, let's save that. I think I'll put that in here. I'm just doing some creation of a project here, so I do this, and I'm gonna get it all in. So let's go here. No, not that one. This. I'm so sorry. I'm so tired now. That was ridiculously long to get that done. I was not expecting that at all. CMD. Git status. What we're going to push it is not a Git, so Git init. Let's see if we can get a nice nice Git ignore for this. I guess it would just be I just don't want the virtual environment stuff basically. So if I just open that up, put .vmv, that should probably do the job. Do git status. That makes sense to me. We'll go git add all, git commit, first push, well, main window is rigged up, and then we want to push it to the actual thing. So how does that work? Like this. I'll have to pull this off actually. Okay, cool. Well, that's done. So that is me done for today. It's good to see it pop up though. That was nice. Yeah. So I'll try. I think maybe next time I should just carry on this, or maybe I'll do it. Maybe do it a little bit later, but off screen. But essentially, it's just important that I have a way of, or a place to add stuff now. So, you know, if I click this, and there'll be like a diagram of something I'm working on, and allow me to start to implement actual things. I know, like maybe like the physics, and try and work out the maths, and just have little fun things that are going on here. Because I want to start ramping up now. I want to start actually getting to the fundamental questions of what I can achieve as a single person with machine learning and the protein database and all the protein folding, all that crap. So I think I'll leave myself there. Yes, cool. And then we'll come back to this because this was not being absorbed when I was reading it. So yeah, thanks for watching if you did, and if you didn't, no worries, and keep learning and keep loving. Bye for now.